You know, it's funny, you've probably used AI a dozen times already today and didn't even think about it. But what happens when that same tech moves out of your phone and into the research lab, where the stakes are, well, life and death? That's exactly what we're going to break down today, the incredible promise, but also the very real peril of AI in scientific discovery.
Okay, check out this quote from Marinka Zitnik at Harvard. It really shows you just how fast this is all happening. She says every single PhD student in her group has their own AI agent, basically a personal research assistant. Think about that for a second. This isn't science fiction. This is right now. We're talking about the next generation of scientists discovering new drugs or analyzing climate data in ways that were honestly impossible just a few years back. So yeah, AI is way more than just another tool. It's becoming a full-on collaborator.
So what even is an AI agent? Well, let's be clear, it's a whole lot more than just a chatbot. Think of it more like a proactive assistant that actually does things. For example, you could say, hey, find the top 5 recent papers on CRISPR and give me the highlights. The agent doesn't just wait for you. It goes out, searches the databases, actually reads the papers, and then brings you back a summary. See the difference? It doesn't just find information, it takes action.
All right, so what can this new collaborator actually do for us? Well, the results are already creating some pretty mind-blowing opportunities. Let's dive into the good stuff first, the promise, and see how this tech is literally helping us see the unseen.
The difference here is pretty much night and day. I mean, think about it. A task that used to take a whole team of researchers months, like manually sorting and cleaning data, can now get done in just a few hours. But honestly, it isn't just about going faster. It's about scale. AI can chew through datasets so massive that no human team, no matter how big, could ever hope to tackle it. And that means we're looking at potential breakthroughs that were totally out of reach before.
And it's not just about static data anymore. I mean, think about your health, right? It's not a single snapshot in time. It's constantly changing. Well, new AI models can actually understand that flow. They can look at something like an ECG, an electrocardiogram, not just as a one-time reading, but as a story unfolding over days or weeks. It can catch these super subtle patterns that might signal a health problem way, way before any person could spot it. And the results? They can be absolutely staggering. Take this number, 96%. That's the accuracy rate, or pooled sensitivity as the researchers call it, of AI models at identifying the disease mpox just from looking at images. I mean, that is an incredibly powerful demonstration of what AI can do for diagnostics. But, and this is a big but, a number like this almost never tells you the whole story.
Right, because for all of this incredible power, there are some really significant risks. Behind those impressive stats, there are these hidden ethical gaps that we just can't afford to ignore, especially when we're talking about people's health and medicine.
This story is actually a perfect, kind of funny, low-stakes example of a really high-stakes problem. So in one trial, an AI agent was put in charge of a simple vending machine business. What did it do? It totally made up fake bank account details and started selling stuff at a loss. It just hallucinated. Now, that's one thing for a vending machine, but imagine that same tendency to just confidently invent things, but applied to a clinical trial or a patient diagnosis. The consequences could be, well, catastrophic.
So, when we talk about these risks, they usually fall into 3 big buckets. First, there's algorithmic bias. The AI can basically inherit our own human biases from the data we feed it. Second, there's what we call the black box problem, which is a fancy way of saying we often have no idea how it's making its decisions. And third, when it inevitably gets something wrong, who's responsible?
Okay, let's talk about bias. An AI is only as good as the data you train it on. It's that simple. So if the datasets you use to train a medical AI mostly come from one group of people, its ability to make accurate diagnoses for everyone else could be dangerously flawed. You see, the model doesn't just learn facts, it learns all the biases that are baked right into those facts.
And that leads us to this massive trust issue. Just imagine for a second, your doctor recommends a pretty serious medical procedure, but when you ask why, they just say, "I can't tell you." Would you trust them? Of course not. Well, that's the black box problem. We're being asked to trust this completely opaque system with our health, and we have no way to check its homework or understand its logic.
And this is the question that's keeping ethicists and lawyers awake at night. If an AI model screws up and makes a critical error in a clinical trial, who's on the hook? Is it the company that built the AI, the researcher who decided to use it, the institution that signed off on the study? Without any clear rules, this huge accountability gap is a massive roadblock to actually using this tech safely and responsibly.
Okay, so remember that incredible 96% number for detecting mpox? Let's circle back to that for a second, because here's the fine print. The very same study that came up with that number also reported high concerns about bias, and they noted the models had poor generalizability. What that means in plain English is that, yeah, it worked great on the test data in the lab, but it might completely fall apart in a real-world clinic with diverse patients. It's the promise and the peril, all wrapped up in a single study.
So where does that leave us? How do we get all that incredible promise without the peril? Well, the answer isn't to just hit the brakes. It's about building smarter. It's about creating AI we can actually trust. And that has to start by putting people right back in the center of this whole equation.
When you look at the nuts and bolts, you find some really shocking stuff. A recent review of consent forms for digital health studies found these massive gaps. I'm talking fewer than 10% of them even mentioned fundamental rights, like how you can get your data removed or what happens if a company makes a profit off your information. It's like we're trying to drive a spaceship with a steering wheel from a Model T. The rules just haven't caught up to the tech.
So, to fix this, experts are laying out a new set of rules for the road, a real framework. First up, we have to mandate diverse and representative data to fight bias from the start. Second, we need to require robust external validation, meaning you have to test these things in the real world, not just in a sterile lab. Third, and this one is crucial, you have to maintain a human in the loop for oversight. Someone has to be there to make the final call. And finally, you've got to foster collaboration. Bring everyone to the table, scientists, doctors, ethicists, and yes, patients too.
Look, at the end of the day, AI isn't just another tool in the toolbox. It's a whole new frontier, and it comes with all the amazing potential for discovery and all the real danger that implies. The technology is moving at an absolutely breathtaking speed. The real question, the one we all have to answer, is whether our wisdom, our ethics, and our foresight can possibly keep up.